Hey guys, in this example we're going to look at a function and figure out how to find its domain and range. So the function that we'll be looking at is this one. Y is the square root of x minus 3. So we're going to find its domain and its range. Now let's turn to the domain first. The domain, as you remember from the module 1, is the set of allowable inputs for this function. And the set of allowable inputs, in other words, is the set of all x's where that function, that formula, in other words, makes sense. Before going further, it might be worth looking at the structure of this equation. You might see that what's allowable is determined by this square root symbol. So let's look at the square root function in a little bit more detail. You may remember from the module that this is one of the elementary functions, and its graph looks like this. In particular, the allowable inputs for this function are all the positive x's. In other words, all the x's greater than or equal to 0. For us, functions like this, and in other words, what's underneath the square root sign needs to be positive. So the domain will be determined by all the x's for which everything under the square root sign is at least 0. Oops. So if you just swing 3 to the other side, in other words, we get that all x's must be at least 3. And so you can say that domain there is the set of all x's, the set of all x which is real numbers, such that x is at least 3. In set notation, you can write this as close bracket 3 to infinity, open bracket. Let's turn to the range. The range in general is a little bit trickier to work out, but in this particular example, we're going to exploit some of the properties of the square root function to help us get there. So if we look at let's look at the square root graph in the middle. You might notice that this set of outputs are all the y's greater than or equal to 0. In other words, let me rewrite that. Once you've inserted an x, then the square root of x's must be positive. And another useful fact we'll exploit is that this function is increasing, which means that if you start from a point on the x-axis A, move to the right a little bit, so that A is smaller than B, then the square root of A will be no greater than the square root of B. Alright, so to determine the range, what we'll do is we start with an allowable input. So we take an x from the domain, that is, x is a number at least 3, and this means that x is greater than or equal to 3. So we swing the 3 back across, and we're going to build this up until we get to our original function. So at this point you can take square roots both sides, and we're allowed to do that because the square root function is increasing. So what have we achieved there? Well, the left hand side is actually the values for y, the right hand side is just 0. And that equation there actually gives us the range of our function. So our range is, in other words, all the y's such that y is greater than or equal to 0, or in set notation from 0 to infinity.